Hey 8th grade, in this next lesson we're going to take those factoring techniques that we looked at in the last video and apply them to solving some polynomial equations of higher degree. The last unit we looked at how to solve quadratic equations, and so these equations here are going to be degrees 3 and higher. The steps are going to be pretty simple though. If you know how to solve a quadratic and you know how to factor, you're going to be able to solve each of these equations. Step 1 is to get everything on one side, so we're going to set one side equal to 0, just like we do with quadratics. Step 2 is to factor completely, and then step 3 is to use the zero product property and solve each factor that you end up getting. Okay, so I'm going to jump right down to example 1 and show you how this works. So just like with quadratics, we want to get everything on one side. So the first thing I'm going to do in number 1 is I'm going to subtract that 14x cubed on the right side over to the left side, and that's going to make my right side equal to 0. So I get the equation 2x to the 5th minus 14x cubed plus 24x equals 0. From there, I'm going to factor. The first thing I want to check for is a GCF. I see that I can take out a GCF of 2x for this one, so I'll factor out my 2x. That's going to leave me with the trinomial x to the 4th minus 7x squared plus 12, all equal to 0. From there, I want to check my trinomial. Okay, I've got x to the 4th minus 7x squared plus 12. Well, I know of factors of positive 12 that combine to get negative 7. I can use a negative 4 and a negative 3. And because the exponent on this middle term is half that of the exponent on the first term, I can factor this like a regular trinomial. Okay, so I know I'm going to use a minus 4 and a minus 3 in this. Okay, the only difference is instead of putting x minus 4 and x minus 3, because we have an x squared in the middle and an x to the 4th out here, we're going to use x squared minus 4 and x squared minus 3. So we're going to factor that just like we would a quadratic, except we're factoring it into x squareds because of this x to the 4th here. And again, we still have this 2x that we factored out that we're bringing down every time. Now I have two binomials, so I want to check those for my differences of squares, my differences of cubes, or my sums of cubes. I see right here that x squared minus 4 is a difference of squares. So I can factor that into x minus 2 times the quantity x plus 2. X squared minus 3 is not a difference of squares or a difference of cubes, so I can't do anything with it. I'm just going to bring it down. Should have had an equal 0 up here. And then that 2x, same thing. My GCF, I'm just going to bring it down. And so now I have this equation, 2x times the quantity x minus 2 times the quantity x plus 2 times the quantity x squared minus 3 equals 0. From there, we've factored completely now, and from there we're going to set each of these different factors equal to 0 to find what x equals. Okay, so we have this 2x first of all. So we know this is one of the possibilities. The quantity 2x could be equal to 0. So if that's the case, then x itself is equal to 0. Okay, so I know the number 0 is one of my zeros for this problem. Okay, another possibility is x minus 2. If x minus 2 is equal to 0, then x equals positive 2. So positive 2 is another one of our possibilities. X plus 2 could be equal to 0. So if that's the case, then x would be equal to negative 2. So negative 2 is another possibility. So I can write 2, negative 2 here, or I can even write it as plus minus 2. And then finally, x squared minus 3 could be equal to 0. Okay, for this one right here, if x squared minus 3 equals 0, then we know x squared is equal to positive 3. To find what x equals for this case, we just have to take the square root of both sides. So x could be equal to plus or minus radical 3 for this last scenario here. So we actually end up getting 5 different solutions to this. Okay, we get 0, positive 2 and negative 2, or plus and or minus radical 3 are our 5 different solutions or 5 different zeros for this problem. Okay, number 2, same thing. We're going to set equal to 0, which this equation already is, and then we're going to use our factoring techniques. 2y to the 6th minus 18y squared. The first thing I can do is factor out a GCF of 2y squared. So I'll do that. That's going to leave me with the quantity y to the fourth minus 9, all equal to 0. Y to the fourth minus 9 is a binomial, so I'm going to check that for my three possibilities: differences of squares, differences of cubes, or sums of cubes. This is in fact a difference of squares. This factors into y squared minus 3 times the quantity y squared plus 3. My GCF of 2y squared, I want to remember to bring that down, and that's equal to 0. Okay, from there I want to check these remaining binomials for differences of squares or difference or sums of cubes. We have y squared minus 3 and y squared plus 3. 3 is neither a perfect square or a perfect cube, so I can't factor either of these anymore. So now I'm done factoring. Okay, so I'm going to now do the same thing I did in the last problem. I've got three different quantities here. I'm going to set each one equal to 0. The first one I have is 2y squared, my GCF. So if 2y squared is equal to 0, okay, then we know y squared is equal to 0. Taking the square root of both sides there, the square root of 0 is still 0. So we get y equals 0. The only thing you want to be careful here, though, is that this is a multiplicity of 2. Because of this squared term right here, okay, because we factored out a GCF of y squared, this means that 0 has a multiplicity of 2. Okay, so that's one of our zeros. We have a few more to find. Y squared equals minus 3 equals 0 is another possibility. So if y squared minus 3 is equal to 0, that means y squared is equal to positive 3. And so just like the last problem, when we take the square root of both sides, we get y is equal to plus or minus radical 3. Okay, so another possibility for zeros are positive and negative radical 3. And then finally, if y squared plus 3 is equal to 0, that means that y squared would be equal to negative 3. If we take the square root of both sides for that equation right there, we get y is equal to plus or minus I radical 3. So we actually get two imaginary answers for this as well. Not only plus and minus radical 3, but also plus and minus I radical 3. So for this one, we have 0 with multiplicity 2, plus or minus radical 3, and then plus or minus I radical 3 for our solutions. Moving on to number 3, we have the equation x to the fourth plus 343x equals 0. This one is already set equal to 0, so I'm just going to start factoring. I can factor out a GCF of x for this one. When I do that, I'm left over with x cubed plus 343. Okay, so I have a binomial. Again, I'm going to check that for my differences of squares, my differences or sums of cubes. It's a sum, so the only possibility for this is a sum of cubes. X cubed is a perfect cube, and 343 is also a perfect cube, so this one will factor using our sums of cubes rule. So I'm going to create a binomial and a trinomial here. I'm going to go ahead and bring my x down. First thing we want to do for a difference of, or for a sum of cubes is to use our SOAP. So we're going to do same, opposite, always positive to get our signs right. The cubed root of x cubed is just x, and the cubed root of 343 is 7. So our binomial will be x plus 7. And then to get our trinomial, we're going to square this x to get x squared. We're going to square the 7 to get a 49. That'll go at the end here. X times 7 is 7x. Okay, so this is how number 3 factors. The one nice thing, like I said in the last video about sums and differences of cubes, is this trinomial here that you get as the result of a sum or difference of cubes will never factor further. Okay, so we know we're done factoring now. Now I'm going to set each of these quantities equal to 0 and solve for x. So first of all, I have just my x. So one possibility is x equals 0. That's just going to have multiplicity 1 right there. Another possibility is x plus 7 equals 0, so that means x could be equal to negative 7 as well. So negative 7 is another solution. And then finally, I have this trinomial right here, x squared minus 7x plus 49. As I just mentioned, the trinomial in a sum or difference of cubes will not factor any further. The bad part about this is that means we're going to have to use quadratic formula. Every time you factor a sum or difference of cubes and you're solving an equation, that remaining trinomial there, the only way to solve it is by using the quadratic formula. Okay, so let me show you what I mean here. We know that this trinomial here, x squared minus 7x plus 49, okay, we know we have to set it equal to 0 in order to get our other solutions to this whole large equation here. Okay, so now we basically created a new quadratic equation for ourselves. It's not going to factor, and the only other method really to use on this one is the quadratic formula. Okay, so I'm going to set up my quadratic formula for just this trinomial right here. That's going to allow me to find my remaining zeros for this overall equation that I'm doing. So I'm going to do x equals, in this case my b value is -7, so I'll do x equals positive 7 plus or minus the square root of b squared minus 4 times a is 1, c is 49, all over 2 times, again, a is 1. So that's going to give me 7 plus or minus radical 49 minus 196 all over 2. You notice you're going to get a negative underneath your radical. You end up getting a radical negative 147. And so we know for this one we're going to get some imaginary answers here. Okay, so radical of negative 147 actually simplifies to 7i radical 3. You can break 147 up into 49 times 3, and then take your I out as well. So that means that this solution to this quadratic equation becomes 7 plus or minus 7i radical 3 all over 2. Okay, and so that right there is going to be the remaining two zeros in our overall equation. Okay, so this was the solution to this trinomial right here when we set it equal to 0. That means that's going to go down here in our final answer. And so we're going to get two more solutions from that plus minus sign, 7 plus minus 7i radical 3 all over 2. So we got two real zeros, 0 and negative 7, and then two imaginaries from this trinomial here. Okay, we're going to try another one similar to that. X cubed equals 125. This is number 4. For this one, I do need to set my equation equal to 0, so I'm going to subtract 125 from both sides first. That's going to give me x cubed minus 125 is equal to 0. I notice now I have a difference of cubes, so I can factor this into a binomial times a trinomial. If I use my SOAP, same, opposite, always positive. The cube root of x cubed is just x, and the cube root of 125 is just 5. So I'm going to get an x minus 5 here for my binomial. My trinomial, x squared will be my first term. 5 squared is 25, will be my last term. My middle term will be x times 5, or 5x. Okay, so now let me show you again how this works. The binomial, okay, we can set that equal to 0 to get one of our solutions here. If x minus 5 equals 0, then x equals 5. Okay, so one of our solutions to this overall equation is just positive 5. The other solution we're going to get by setting this trinomial equal to 0. So x squared plus 5x plus 25 equals 0. And in order to solve this, because we got it from factoring a difference of cubes, we have to use quadratic formula. That's the only way this is going to work. So we're going to set up our formula, just like for number 3, with x equals, we'll use a negative 5 here, plus or minus square root of 5 squared minus 4 times 1 times 25, all over 2 times 1. When I simplify my radical, I get radical 25 minus 100 all over 2, and that simplifies to negative 5 plus or minus radical negative 75 all over 2. Okay, we know radical 75 will split up into radical 25 times radical 3, which becomes 5 radical 3. We also have a negative underneath it, so this actually becomes 5i radical 3 when we simplify it. Okay, and so putting everything else in there, our imaginary solutions become negative 5 plus or minus 5i radical 3 all over 2. So that is going to be my remaining two zeros to this problem. Negative 5 plus or minus 5i radical 3 all over 2. Okay, so basically anytime you're factoring a sum or a difference of cubes, okay, when you're solving these equations, you know you're going to have to use the quadratic formula at some point in there to end up getting a couple of your solutions. That's what we did in 3 and 4. We took our trinomials, we set them equal to 0, and then we used quad formula to get our imaginary solutions. I have one more problem for you. It's number 5. Thankfully, you don't have to use quadratic formula at any point for this one right here. We do need to set this equation equal to 0, so I'm going to subtract 4 from both sides. That's going to give me x to the 4th minus 3x squared minus 4. I have a trinomial there, similar to number 1, so I'm going to factor this by finding factors of negative 4 that combine to get negative 3. And those numbers would be negative 4 and positive 1. Since we have an x to the 4th here and an x squared in the middle, this factors into x squared minus 4 times the quantity x squared plus 1. We should notice that x squared minus 4 now is a difference of squares. So that will factor into x minus 2 times the quantity x plus 2. X squared plus 1, you might be tempted to factor that. Please don't. It's a sum of squares, and sums of squares will not factor. Okay, so we just have to leave that as x squared plus 1. So now that we've factored this completely, we're going to set each of these quantities equal to 0. So x minus 2, if that is equal to 0, then x is equal to positive 2. So one of our solutions to this equation is going to be just positive 2. Another solution, okay, if we set x plus 2 equal to 0, then x equals negative 2. So another solution is negative 2. So I can write this as plus or minus 2 to get both of those. And then finally, if we set x squared plus 1 equal to 0, that means that x squared would be equal to negative 1. If I take the square root of both sides, I get x equals plus or minus I. So my final two solutions to this would be plus or minus I. Okay, so it's a lot of factoring, it's a little bit of quadratic formula, and a little bit of remembering what we did with imaginaries. Okay, it's going to take some practice to get really good at these, as does all things in Algebra 2. But if you have any questions over just what we did in this video, please shoot me an email so I can get to those before we discuss this in class. Until I see you, have a nice day. You're all wonderful people. Take care.